So we're going to start with a little bit of housekeeping regarding the quiz that I posted on Monday. So a couple of things. If you didn't get the email that I sent out to everybody, there are going to be some cases where I have to manually go in and grade certain questions like short answers, sometimes fill in the blanks, because the computer, for the fill in the blanks, the computer is looking for the exact answer that I type in. So one of the cases that happened was I typed in mic pre instead of microphone preamp or mic preamp. So if you type something other than mic pre, it registered it as wrong. I've since gone and corrected anyone who had the right the right term, just not in the exact way that I said it. Now I wrote it as mic pre just because that is the kind of common term to use for a microphone preamp. So you'll hear when people talk about them, they'll refer to them as mic pre's. So that's why I did that. As far as the short answer, I mean, there's no way that I can type out an exact answer that I would be expecting you to give. You've got a lot of leeway there. So as long as it's correct, you got full credit for that question as well. So there was also what looked like a problem with question 1. I don't know if I somehow screwed up on assigning what the answer was in D2L, or maybe I just didn't really explain it well enough in class the other day, or last week, I guess. But question 1 asked, what are some functions of a typical mixer? And everyone who answered it seemed to select answer A, which was it brings microphone level signals up to line level, which is absolutely true. We did, though, talk about EQ on each of those channels and outputting the mix to our speakers. So maybe I just wasn't clear on something about that, but basically any mixer that you're going to be working with is going to have EQ available for every channel. And also, I mean, the whole point of a mixer is to mix those signals together and then output them to our speaker system. So just in case that wasn't clear, all three of those answers are correct. So I think there should have been an option for A, B, and C, and that's the answer it was looking for. So if there's any questions about any of that, please let me know. Otherwise, we will get going with signal sources and signal flow. And so signal is, when we refer to signal, we're talking about an electrical signal. And it's going to come from really one of two sources, or there are two sources of signal that we're going to be getting from our stage. That's either coming from a microphone or coming from a DI box, often called a direct box. The DI stands for direct injection, because you're basically directly injecting the signal from an instrument, rather than with a microphone, which is converting sound pressure waves into an electrical signal. So those are the two types of signal we're going to be capturing in a live performance. And again, so a microphone is going to take sound pressure and convert it into an electrical signal. The direct box or the DI box is going to just take a signal straight out of an electric instrument like a keyboard, possibly an electric bass or an electric guitar, a computer output, something like that. And so I'm going to talk a little bit about just kind of the basic functions and construction of not so much the construction, but basic functions of a microphone and a direct box. If you took Music 2071 or 3071, we talked about the construction of microphones and exactly how they convert the energy, the acoustic energy, into electrical energy. So if you took that class, you learned a little about that. If you are going to be taking that class in the future, we'll dive a little deeper into that. But for our purposes, we're not going to go super in the weeds on that. But basically, microphones are what's called a transducer. Transducers are any piece of equipment that converts energy from one form to another. So like we just talked about, a microphone converts acoustic energy in the form of sound pressure waves that travel through the air. So it converts acoustic energy into electrical energy, an electrical signal, which we read as a change in voltage. Other examples of transducers are speakers. In fact, speakers are basically the exact opposite of a microphone. Speakers take an electric signal and convert it into acoustic energy in order to create sound pressure waves that then our ears interpret as sound. So speakers are also transducers. Even light bulbs are transducers. They take electrical energy and convert it into light energy. And so basically the way a microphone works is those sound pressure waves that move through the air hit the diaphragm inside the microphone, which is a really thin membrane in the capsule of a microphone. And those changes in air pressure, which sound is literally defined as just a change in air pressure or fluctuations in air pressure. So those waves hit the diaphragm of the microphone, and it moves. It's imperceptible to the human eye. It's moving so slightly. Pardon me, but it's movement enough to generate an electric current. Again, we're not going to go super into detail on how that works. If you're curious, please let me know. I'm happy to explain it. But for our purposes of this class, the kind of physics of it, the mechanics of it, aren't super important to us. So the capsule or the diaphragm moves inside this microphone, responding to the sound pressure waves. That gets converted into an electric signal. That signal travels down the XLR cable into our mixer. And so that change in voltage and the current associated with it, that is what we call the signal. And so a good analogy to think about in terms of how to understand current and voltage is if you've got a water hose, the current would be how much water is passing through the hose. Current is measured as like an amount over time. So it's how much water would be going through the hose or how many electrons are flowing through a cable, right? Whereas the voltage would be like the water pressure. Is it a slow trickle or is it like a pressure washer, high pressure nozzle? And so if there is no voltage, there can be no current. And we talked briefly last week about Ohm's law. And so that tells us that the voltage is equal to the current times the resistance in a circuit. So what that tells us is that if there's no change in the resistance, then voltage and current are directly proportional. So if the voltage goes up, the current will go up. If the current goes up, that is due to an increase in voltage. And again, not crucial that you understand the math or physics behind that, but it's just interesting to know, kind of what's going on under the hood, so to speak. And so again, once the microphone is converted the sound into an electric signal, that signal is carried down through the XLR cable into our mixer. That signal, like we talked about, is called mic level signal, and it's a very low level signal. It's a very low voltage. The microphone is not outputting a lot of power. So that is the purpose of the mic pre, or the microphone preamp. It boosts the level of that signal, increasing the voltage, and then the rest of the circuitry of the mixer can then handle the processing we're going to do, because it requires a stronger signal. And so this slide just shows a schematic of a microphone preamp, and next to it is a really basic circuit board mic pre. And so these two images don't totally correlate to each other. The circuit diagram is not exactly what is on this circuit board, but it's just an example to show you. So a mic pre, and really all electronic circuitry, is just a handful of basic components. You see where it says like R1, R2, R3, those are resistors. C1, C2, etc., those are capacitors. And the little triangle shape towards the right of the schematic, that's called an op amp, or an operational amplifier. And on the circuit board, that is the little black rectangle with the 8 legs, 4 on each side, kind of looks like a little bug. That is an integrated circuit called an op amp, operational amplifier. And that is that is a necessary part of an amplifier circuit to help boost that voltage. So just an example, again, just to kind of show you an under the hood look at what's going on in our mic pre, which again is the first circuitry that the input hits when it comes into the mixer, because we need to get that mic level signal up to line level to be able to do anything else with it. And as far as DIs, that is just like a microphone. It's to bring an instrument signal into the mixer. And so these can come from things like electric guitars, electric bass, keyboard, computer. Those are typically unbalanced outputs coming from these instruments. If you're a guitar player, you know that 1/4-inch cable that you plug from your guitar into the amp is just a tip and sleeve, as opposed to a tip ring sleeve. So a balanced 1/4-inch cable has 3 conductors, two conductors and a ground, and an unbalanced just has 1 conductor and a ground. And so the output from from one of these instruments is going to be a 1/4-inch unbalanced output, or in the event of like a computer, your laptop would be its headphone jack. That oftentimes is a balanced output, your headphone jacks, because it's carrying both a left and a right signal. So the slide actually is, I could have made that more clear. But a lot of times coming from a computer output, that will be a balanced signal, but it's still not the right level and not the right impedance. And impedance is just for our purposes, we can consider it resistance. It's not the right impedance to match it with the circuitry in the mixer. So the DI does a couple of things. One is it's going to take an unbalanced input and spit out a balanced output. Also, it's going to match the impedance from your instrument to the mixer. And that's important just, again, for the circuitry that's going on behind the scenes for these two units to be able to communicate and pass signal properly. That impedance needs to be matched. And so an instrument typically has a very high impedance, whereas our mixer is at a much lower impedance. And so the DI, the direct box, has kind of like a buffer circuitry in it that matches those two values. When working with a DI, you can, most DIs, at least decent ones anyway, will have not just a balanced output that will go to our mixer, but it'll also have a through port. It's another output that's really just passing the unbalanced signal as if you were just plugging from, say, your guitar into an amplifier. So that allows us to kind of have the best of both worlds, really. We can plug into the direct box and go straight out of that direct box in the throughput into an amplifier on stage, but then also take that balanced XLR output into our mixer. So we can, say, put a microphone on the guitar amp and record that, or play that through the house, and we can also take the direct signal straight from the guitar through that balanced XLR out, also to the mixer to either record and or play through the house. And so as far as our stage is looking, if we've got a whole lot of instruments, a whole lot of microphones on the stage, there's going to be a lot of XLR cables going around. And this can be, it can get messy. It can get messy real quick. And it can also be a tripping hazard. So one thing that's really convenient and helps kind of keep things tidy, keeps things a little safer than just a bunch of cables all over the stage, are snakes. Sometimes you'll hear the term stage box. Those technically are two different things, and we can talk about the differences between those maybe another time. But you can see here on this image, basically a snake is a box that you'll set somewhere on stage, kind of a central location, where all your microphones will plug into this box. And then coming out of that box is just one single cable. It's a beefy cable because it's got a lot of connections, a lot of conductors going through, basically it's a one big wire with a whole bunch of wires inside of it. Right, so you can run that single cable back to your mixer, or a lot of times on a stage there'll be a panel that you'll plug your mics into, that then from that panel gets run to the front of house mixer. So it keeps things cleaner on stage, prevents or reduces at least a lot of tripping hazards. And another important thing is it makes it easier to trace back our cables if we need to. For instance, if you've got for whatever reason you're not picking up say you've got a trumpet and you've got a mic on the trumpet, you've got a whole lot of mics on the stage, but for whatever reason the trumpet player's mic is not getting to your mixer. Well, if you've got 30 cables on the stage, all kind of zigzagging around each other, it's going to be hard to trace that back and see if maybe something got plugged in wrong, or maybe the cable's just not seated properly in the panel or in the microphone. Maybe it got patched to a wrong input. And with a snake, it shortens the cable run from the microphone to where you're plugging the other end of that XLR into. So it makes it easier and quicker to kind of troubleshoot and trace down maybe a mispatched cable. And anything that saves you time when you're talking about live sound is typically a better option, because you only have so much time. I mean, I'm sure everyone's been to some kind of concert or performance where it starts late. Well, you typically want to try to start as on time as you can, and you only have so much time. You know, you can't put off a show forever. So anything that helps speed things up, especially when you're trying to troubleshoot something, solve a problem, you want to set yourself up to be able to do that as quickly as possible. And so snakes can help with that. So this next slide shows you what I was talking about with the wall panel. So like in our, really all of our concert halls or performance spaces have these panels in the wall, because the mixer is in a different location a lot of the time. In Dvorak, the mixer is way in the back of the room. You know, it's about 100 feet from the stage. So we can't run dozens of 100-foot long XLRs from the stage all the way to the back of the room. So those XLRs go from the mic into one of these wall panels, or oftentimes from the mic into a snake, and then from the snake into these wall panels. And then you can see on the rear of the panel, from that wall panel then, there are cables physically going behind the wall and usually under the floor, all the way back to our front of house mixer. And so here's just a couple little sketches I made of you know, how much cleaner it can be on stage when you're utilizing one of these snakes. So kind of cheesy drawings, and obviously, you know, it is what it is, but I couldn't find any good images online of, oh, here's a setup where they're using a snake, and here's a setup where they're not. So I just figured I would draw a couple of examples here. And even though the drawing that I made of without the snake, that's even cleaner than it would typically look on stage, probably, if you were just running cables straight from your mics to one of those wall panels. But again, it just introduces more tripping hazards. You're going to have to tape down a lot more cables, so you're going to use up a lot of tape, which then at the end of the night, you got to rip all that tape off the ground. And anything that can save you time, save you potential problems, hazards, try to shoot for that. Because again, time is money. And if you're talking about before the show, well, time is short. You only have so much time. And then after the show, you don't want to be there for hours pulling tape off the ground if you don't have to be. So again, it's just kind of like a working smart and not hard kind of scenario. So there's also digital snakes, and these would obviously really only be utilized if you had a digital mixer. And we'll talk more about some of the differences and similarities between analog and digital systems. And but while we're talking about snakes, I want to point out that there are obviously digital versions of these. And the beautiful thing about this is that once you've got your mics plugged in, you can see on the front of this panel, you've got all your XLR inputs. And then on the rear of the panel, it's Ethernet. So instead of having 10, 12, 24, 32, maybe even more XLRs, depending on how big your stage setup is, all going from your snake to a wall panel, or from a snake run to your console. You plug them all in on the stage, and then you have one Ethernet cable taking all of that back to your mixer. And so that is that's what we refer to as audio over Ethernet or audio over IP. And it can carry with very, very low latency, very little to no delay. Full resolution, 24-bit, 48K audio, and many, many channels of it. And if that wasn't clear, if any of that was confusing, or don't worry about it now. We will talk a lot more about that at a later time. So, wireless microphones are they're a beautiful thing, and they're also sometimes a pain to deal with. But when they work, it's amazing. And so a lot of facilities, a lot of venues will have wireless microphones available. There's probably a lot of places where they only have wireless microphones. If you're doing a lot of setup changes, wireless microphones are super convenient, way less hassle. You don't have to move cables. You don't have to, nothing gets tangled up. You're not moving mics around and then twisting up cables as you go. It's just, kind of grab and go, move it where you need it, when you need it. Easy to tear down, afterwards. There's no cables to wrap. Obviously no cables taped down to the stage. So set up and tear down, super easy. Again, when it works, it's brilliant. When there's issues, it can be a headache. And we'll definitely talk more about some of the potential issues when we talk about troubleshooting and kind of problem-solving techniques. But so a wireless microphone works just like, just like a standard microphone. It's, excuse me, taking, or it's converting sound pressure into an electrical signal. However, then that electrical signal is converted into a radio wave. Now, how does that work? I have no idea. Pardon me. So yeah, the physics of that, the way that actually happens, I have no clue. I wish I did. But it converts it into a radio wave, and then transmits those radio waves. Well, radio waves just propagate, in all directions, and what am I trying to say? It's obviously not a cable, so it's not anywhere you are in the room. As long as there's a receiver with an antenna, it will pick up those radio waves. So you don't want to be too far, because the signal is only so strong, right? So the size of your space can be a factor. You also typically would need that receiver somewhere near your console or your mixer, because you need to take the output from that receiver and put it in the mixer, right? So usually you'll see the receiver wherever the mixing console is, and then at the receiver end, it's converting those radio waves back into an electrical signal that we then take as an output from that unit and plug it into our mixer. Wireless mics they have a pretty narrow band of frequencies that they operate on. This is usually to help with or to minimize kind of crosstalk, like if you have a couple different wireless systems where you don't want one receiver to be picking up the transmission from the wrong microphone. So there's designated frequency bands that they operate on, and those frequencies are regulated by the FCC, and that's to ensure that like your microphone system isn't operating on the local radio stations airwaves, or the local airport isn't picking it up, things like that. It's to just keep the radio bands kind of distinguishable, differentiate one from the other, so you're not, your wireless mic isn't getting picked up by a police car or something. And so here's just another kind of sketch I made, and it's not great, but I hope it's that you can read it just fine. But just showing kind of a real basic signal flow. So we've got a few sources here. Here we've got a trumpet who's playing into a microphone. We've got a keyboard, and we've got a wireless microphone here. So those are our three sources. They're labeled 1, 2, and 3. We do have an XLR snake on our stage here. So the microphone from the trumpet is plugged into the snake. The keyboard has a unbalanced quarter-inch cable going to a DI box. Going out of that DI box, XLR into our snake. And then from that snake, that's going straight into our mixer on inputs 1 and 2. We also have this wireless microphone that's sending a radio frequency or radio wave. That radio wave is getting picked up by our wireless receiver, which is then outputting balanced XLR going into our mixer. We mix our signals together. We get a balance that we like. It goes out of our mixer as a stereo pair, left and right, going into a power amp. That's at line level, by the way. So everything, once it's inside the mixer, is now at line level. We take two line outputs, left and right. Those are either going to be XLR or quarter-inch balanced line level outputs going into our power amp. And then from the power amp, we're going speaker cable carrying speaker level signal out of the power amp into our left and right speakers. So hopefully that's easy enough to follow. Now, within the console or the mixer, you'll hear me interchange those words, mixer, console, mixing board. Sometimes you'll hear people just say the board. So those all refer to the same piece of equipment, right? So hopefully that hasn't been confusing if I've been going back and forth there. But so inside our mixer, there's a whole nother signal flow going on where, as far as what components, what circuitry is our signal is passing through in a certain order, right? And we'll talk more about that when we talk about analog and digital consoles. But for now, this is kind of just a real basic stage setup with a few microphones, a couple microphones, an instrument source going into a snake, going into our mixer, from our mixer to a power amp to our speakers. Now, because these speakers are getting their signal from an external amplifier, that means these are passive speakers, right? Passive speakers have no internal amplifier in the speaker cabinet, which is why they require an external power amp. So if these were active speakers, the power amp would be unnecessary, and we'd be taking line level out of the mixer straight into the back of these speakers, where then the speakers take that line level signal, amplify it to speaker level, and then and that's what powers the speakers. So in this example, we've got two passive speakers here. And then lastly, so we also need to get some sound back onto the stage. The musicians need to hear themselves. They need to hear each other. And, pardon me, if you're in a really small space, maybe this isn't always necessary. But if things are going to be loud, or if it's a big stage and people are kind of spaced away from each other, then we're going to need some kind of monitoring for the stage. And so stage monitors are often called wedges. So you can see this this image here. They're called wedge monitors, or sometimes just wedges, because they've got this wedge shape, and that shape is designed so that it sits on the ground but kind of points up at a angle up towards the musician. There's also There's also in-ear monitors, and those could either be wired or wireless. And there's pros and cons, obviously, like with anything, but it's probably, I would say it's more common to see wedge monitors in most places. That's definitely not always the case, and I think more and more facilities are implementing in-ear monitors. But a lot of times, if musicians want to have in-ear monitors, they're typically going to have their own setup. Probably shouldn't say typically, but if it's something that a group really wants to have, or that's what they're comfortable with, that's what they prefer, they're probably not going to expect every venue to have that available. So, because not all of them do. But any facility should at least have some stage monitor options. And so the way, I did not put another signal flow chart here. But these, I just put another slide. I didn't make another signal flow image here for you. But so the audio that we're sending to these speakers, to these stage monitors, is coming from our mixer. Obviously, the sound has to come into our mixer, sound has to go out of our mixer. So we can build these kind of sub mixes that are typically called monitor mixes, and depending on how many sends your mixer has, so you're sending audio out of the mixer, right? However many of these sends you have available is how many monitor mixes you can have. So if you have 4 sends on your mixer available, then you can have 4 independent monitor mixes, meaning the drummer could have their own separate mix. The guitar player, the bass player, they could each have their own. The vocalist could have their own. So you could, if you had 4 sends on your mixer, you could have up to 4 completely independent mixes going to stage monitors. And those are Well, there's going to be, again, either active or passive speakers. If you're in a smaller setup, you might have an active monitor where you can go just straight out of your mixer, line level, into an active stage monitor that, because it's active, would have its own amplification, would have its own power amp in the speaker cabinet. But at least like in our rooms, they're all passive, so there's amplifiers in completely different rooms that's going out of the mixer, line level, into those power amps. And then from those power amps, we have speaker cables run to those same wall panels where our XLRs plug into. There's speaker tie lines where we have speaker level signal coming out of there, and that we would plug into our stage wedges. And so that's kind of a run through of how our signal sources are coming to our board, the signal flow associated with all that. And like I said, we will dive more into the kind of next level of signal flow with what's going on inside the mixer at a later time. That will probably be next week. But anyway, I hope that was clear enough. Please let me know if you have any questions. And you can always reach me by email. Hopefully having this audio associated with the slides is helpful. Let me know if this was beneficial, and I will do this moving forward.